So to hopefully finish this, apologize, long series of videos about the anti-Sevian triangle, which is filled with properties, let's look at a few more triangle centers of it over family of equilaterals. There's a couple more really curious properties, okay? So here is, for example, the symmedian point x6. And before we do anything, what's the locus of the symmedian point? Okay, not over the family of equilaterals, but over rotation of P. Is that what I'm doing? Yes. So here's the locus of the symmedian of my anti-Sevians, which is this nice three-leaved clover-like figure. Very pretty. We're usually not focusing on this. We're actually focusing more on the locus of the point by keeping P fixed, right? And actually rotating my Poncelet equilateral family. I'm not using the word Poncelet very much here because this is just a family of rotating equilateral triangles, but this is a Ponceletian family nonetheless, right? Especially when we apply an affine transformation, then you might have to say, okay, this is the affine image of a family of rotating equilaterals. You could still get away with avoiding Poncelet here, but I'll throw in that term every now and then. Okay, so let's go back to an identity affine, so a family of equilateral triangles, and now I want to look at x6. What is x6 doing as I rotate my family? It's doing something quite curious. It's actually sweeping a conic, an ellipse, tangent to the original circumcircle at P, okay, and not necessarily with a set of semi-axes that is readily identifiable. We need to derive algebraic expressions for those, but this I would say is an inherent object because it doesn't matter where P is, right? I'm going to get the same kind of set of axes. And let's look at what happens if P is moved to the exterior. Okay, so this locus of x6 is no longer a conic. It's only a conic, at least in this neighborhood, when I'm precisely on top of the circumcircle. What if I move this guy inwards? Also not a conic. How about if P is exactly on the incircle? Also not cooperating, not a conic. Okay. What if I keep moving this guy inwards? Let's bring in my midlines. And let's approach now the speaker circle. So I'm still sort of a bean-shaped object. And then when I'm on the speaker circle, which I can just do by doing this, I'm still not a conic. Okay? So going further in, not a conic, not a conic. So it looks like the only relevant property here is when P is exactly on top of the circumcircle, in which case I get a nice swept ellipse. Okay, here are the two foci and so on. Let's look at x7 just for fun. The Jargon point. I'm going to ignore this thing. Yeah, I can just very quickly show you guys what happens when P is outside, P is inside. Doesn't look interesting, right? Let's go to the Nagel point. Also doesn't look interesting. Let's change my locus sampling here. Not getting anything interesting. No conics. How about the Mittelpunkt? Nothing interesting. The speaker center, nothing interesting. X11, complicated thing. X12, X13. So before I actually go there, let me replace P on the circumcircle and just verify that there's no phenomena here going on in either one of these centers. For example, the speaker looks very much like an ellipse, like a hyperbola, but it's not being detected as so. Okay, so this is a non-conic. And I'll just go back here, X9, X8, X7, non-conics, X8, X9, X10, non-conics. If I go to my inner, X10 is a complicated curve, 9, 10, 8, 7, also nothing special. So let's say that these points are not generating any salient phenomena. Let's go to 13. Here's 13. Now with 13, if P is on the incircle, 13 is behaving as a straight line. Okay, so this is a nice phenomenon. And then P is moved outwards. X13 is not a conic, it's a complicated shape here. It looks like it could be piecewise circular. X13 is often piecewise circular. By the way, if I go back to the inner and I apply an affine, X13 loses its collinear status, right? So it's only a line when I'm exactly at identity affine. I'm at the equilateral family, okay? Now moving P outwards, you can see here that I've lost that nice status, and then when P is exactly on the outer one, it looks like I'm probably getting here. Yeah, so X13 tends to do this. I'm moving along the arc of a circle for a while. It looks like the arc of the circle is twice the radius, but then I have these discontinuous jumps, and then I stay at the center point for some time. Okay, so yeah, this is quite interesting, right? So X13 is actually staying stationary for some time, exactly when the midlines of my family contain P, right? So you have this period here when these two midlines contain P, and then I stay, X13 is stationary during that time, but as soon as I leave that, then X13 jumps to an arc of a circle. Okay, so there's some interest in studying this phenomenon here. How about X14? X14 is going to have something that is going to be complementary to what we just saw. So now it's actually moving along this arc with the triangles moving around, and then it becomes stationary on X14 on P when I'm actually at a complementary zone between my midlines. So it's stationary here. I call these phenomena, and I'm starting to notice them in several different situations, but these are bistable phenomena, in the sense that you have a phase of your locus where you're stationary at a point, and another phase where you're actually moving, actively moving along a separate disjoint locus. So here, if you ignore these two straight lines here, this is bistable in the sense that while the point P is contained between these two midline zones, X14 is stationary at P, and when I'm actually between these other two zones, X14 is going to be moving, so it's going to jump discontinuously from this point to this arc of a circle, and it's going to move here. Let's see if we can just eyeball that. So I'm stationary now, and I'm going to discontinuously jump. You see I'm crossing a midline, discontinuously jump to over there. So I've jumped from here to over there. Now I'm just going to traverse an arc of a circle, and then discontinuously jump again to my stationary phase. So this is bistable. Lots of phenomena that I'm starting to notice that way, and they're quite interesting, right? I mean, who would think that you can have a continuously rotating family of triangles and be tracking the locus of some derived triangle center, and this locus is actually the union of an isolated point and an arc of a circle. Okay, so that's what X13 and X14 are doing. How about X15? X15 is doing, okay, so now it's bistable, but not in the sense that I have a point now. I have two disjoint arcs of circles. So X15 is now moving along two disjoint arcs of circles. Oh yeah, so, okay. How about X16? Same kind of idea, moving along this first arc of a circle, and then when there's an inversion here, this midline is about to cross P, X16 is going to jump to a second arc of a circle up there and go its merry way. So here's another very curious phenomenon, right? Bistable, two disjoint arcs of circles of different radii. What if I move R to the exterior of the circle? Yeah, then it gets more complicated. What if it goes to the interior of the circle? More complicated. The same thing should be true for X15. It's more complicated if it's inside or outside, or if I go into the in circle. So you don't want to go here. There's just too much strange stuff going on. How about 14? Same thing. If I go inside, I'm strange. If I go outside, I'm strange. But if I'm on the outer one, then I have this sort of bistable phenomenon. Same thing should be true for X13. If I'm on the circumcircle, I'm bistable. If I go inside the circumcircle, I get strange. If I go inside the in circle, I'm still strange. And in the speaker circle, I'm nothing. If I'm exactly on the speaker circle, I'm an oval, and if I'm exactly on the in circle, we saw this before, I am a line for X13. Is X14. X14 is nothing, strangely, okay, in this configuration. X15 is nothing, and X16 is nothing. So it's only X13 that has the special case of P being on the in circle and X13 is a line. If I apply an affine here, I lose that, okay? But I'm a collinear with X13 right there. So I think that this concludes the sort of haphazard exploration of a multiplicity of phenomena involving the triangle centers of an anti-Cevian triangle to a family of rotating equilaterals, with or without affine transformations to these equilaterals, and with P being placeable at any point in the plane, including the circumcircle, the incircle, or the speaker circle. So we're going to switch gears in the next set of videos, and we're going to be talking about phenomena which are quite nice, involving pedals and antipedal triangles to the same family of rotating equilaterals. So I'll see you on the next videos.